Hi, I'm Kazuki Takashima from Tohoku University, Japan. I am the second author of this paper, Modular HMD, a reconfigurable mobile head-mounted display enabling peripheral interactions with the real world. This work has been led by our former students Isamu Endo and conducted with our colleagues Marakito Inoue, Kazuyuki Fujita, Kiyoshi Kiyokawa, and Yoshifumi Kitamura. VR HMD is now expected to be used for mobile work context because it can easily create a personal and mobile workspaces. However, current mobile HMD uses full immersive curves, which creates two types of boundary issues. The first issue is that the HMD users cannot see physical objects and devices without removing headset. Such ad hoc physical device interaction during VR experience is required for many of office scenarios. The second issue is more about the social context. Non-HMD users cannot see the face of the HMD users, which makes communication between them quite difficult. Additionally, non-HMD user cannot quickly join the ongoing VR interaction with HMD users. So current HMD configuration has difficulties for ad hoc real-world interactions. To address these issues, many researchers have proposed solutions. MDI uses transparency controllable LCD for side and bottom parts of the HMD, allowing the user to directly see the real-world objects without removing the headset. But it cannot support any ad hoc collaboration with real world. Face display is designed to support collaboration with real-world partners by installing the 3 touch screens on its back. This enables collaborative touch interactions between users beyond the HMD boundary, but it does not support ad hoc device interactions. So there is no coherent solution to support ad hoc interactions with the physical devices and partners. To make HMD functions more flexible, we focused on the modular mechanism. Modular smartphone, shown here, is an interesting concept, where a smartphone device can be divided into several copies, and one of them can be physically rented for partners. This is a convenient way to quickly manage cross-device content sharing between owner and users. We introduced this idea to flexibly control the barrier of the HMD curves and support collaborations with others. So we propose a modular HMD that allows the user to perform ad hoc interactions with real-world objects and partners. The main feature is installing the 3 removable and reusable display modules at the side and the bottom of the central screen. As a basic function, the side and bottom module display the extended virtual views, which will make a larger FOV experience. Each module can be set to the video see-through mode if the user wants to get a situational awareness of the surroundings. In case the HMD user requires physical interaction with the real world, these modules can be physically removed from the HMD and then reused as an interaction devices. So we implemented a prototype using a stereoscopic mobile display as the central screen, 3 iPod Touch for each module, and many of 3D printed parts. It eventually has 6 lenses in total. All lens and display arrangements were carefully designed to make a large FOV, yet user's eye movement range is still within the comfortable viewing angle. The side and bottom modules are on the slider holders. To remove the module, the user slides the inner lens first and then put the module out from the holder. The user can wear a modular HMD just like a regular HMD and can easily see the side module, like this. Using this prototype, we designed several interaction scenarios. As the first scenario, we show its fundamental HMD's capabilities. Here, the user wants to be immersed in a virtual world. Here, side and bottom module display the extended image of the frontal VR content, increasing the user's immersive feeling. The second scenario, the user wants to take a note using a physical pen during VR experience. The user can see the note and the pen by making the bottom module video see-through mode. The third scenario also represents a case of increasing situational awareness. By using video see-through mode as a side module, the user can recognize the person nearby and estimate their intentions. The fourth scenario is solving the boundary issue with physical devices. The user receives a chat message and wants to quickly reply. The user can input the text by removing the bottom module and immediately reusing it as a touch keyboard. The user can directly see the keyboard and own fingers through the bottom opening slot, which support accurate finger manipulations while keep looking at the VR content. Once the typing is over, the user can quickly come back to the original VR experience. The last interaction scenario is collaboration between HMD and non-HMD users. This movie now shows HMD users' perspective. A partner approaches to an HMD user who is now modeling a 3D content, and they want to perform a quick collaborative content editing. To do this, the HMD user can share his current content quickly by physically lending the side module to the partner. Here, the partner can also join the interaction through the module touchscreen, and his input can be also visualized in the VR view. So the HMD user can see the facial behavior of the partner through the side offering. If the collaboration is over, he can come back to the personal work by putting the module back in the slot. Next, this video now explains the partner's perspective in the same scenario. The partner asks the HMD users and gets a side module. The partner can immediately see the content, VR content on the module, and use its touch screen to give instructions. Both users can exchange eye contact and understand how they think each other while collaboration. This interaction creates distributed cross-device workspace and necessary face disclosure by a single set of modular actions. So we performed the user study to understand the fundamental benefits of our modular HMD. Here we show some highlights. So first, we checked the immersive VR experience and found additional extended view were good, but not significant for their immersive experience. We discussed the need for minimizing physical gap between the lenses. Second, we checked ad hoc text typing during VR experience. Our physical interaction via our modular action offer high usability and significantly faster text typing. We recommend this mode for mobile work context. Third, we checked how the side opening slot helps their facial expression exchange. We found it is good for making eye contact, but not good enough to understand facial expression. So we discussed the possible extensions such as installing a small light to illuminate HMD user's face. Last, we checked how modular HMD's ad hoc collaboration works. We confirmed that it provides high usability and smooth cross-device interactions. In this work, we propose the modular HMD, a new mobile HMD concept for ad hoc physical interactions, and its unique benefits were confirmed by our prototyping and studies. Here are limitations and our future work. Thank you very much.